So the last part is I posted a derivation exercise on Moodle. It is kind of, let me see, I think it's this one. Yeah, it's a PDF, and it's a Gibbs sampler derivation exercise for what I call Gamma-Gamma-Poisson. So bear with me. It is nothing too complicated than what we have seen before, but this can be a really great exercise for us to really understand what a Gibbs sampler can be derived in the first place. Okay, so if you remember the Gamma-Poisson stuff that we did, okay, Poisson is a common model for count data, and then we can, it has only one parameter, the rate parameter. So what we did before is that you can have a gamma conjugate prior for this rate parameter. So we derived, I think last week, of how to get that posterior working. So what I'm proposing here is part of the exercise, but also you will see in next chapter, it is an example of what we call hierarchical model. Okay, so first of all, I give the density function 1 and 2 for the Poisson at the top and the gamma, so you can use them coming up. Okay. One thing I want to mention over here is that now, instead of directly just having lambda, so lambda is the rate parameter for the Poisson. Okay, so we're saying that, okay, all of each observations are IID following a Poisson with lambda as the single parameter. So here, instead of giving lambda a particular gamma distribution that we know, I'm proposing that, well, let's try to give lambda a gamma parameter that one of the parameter is unknown. Okay, so instead of like 1, 1 or whatever value that I'm giving the first parameter as 1 and the second parameter, which is unknown, I'm just writing B for it. I'm further giving B another gamma prior distribution. Okay. So to help us get started, okay, so as we know, there are two parameters now in this model. Okay, we have lambda and we also have B. So this is a, so eventually if we derive everything correctly, we're gonna actually come up with a Gibbs sampler. So the few steps at the beginning, which I will let you to try it out. Step 1 is to write out the likelihood function. And as you know, we have both parameters unknown, so we have lambda and B. Okay, so this should be the joint likelihood that you should be writing out. Okay, and then from there, you should also try to write out the joint prior distribution. Okay, so notice that we have a marginal distribution prior for B, and then we have a conditional prior for lambda given B. So think about how you can get the joint prior. And lastly, try to see if you can use the regular technique that we have done so far to get the joint posterior. Yes, go ahead.
Can you give us density functions on the?
Yes, exactly. So you see that at the top, we have 1 and 2. But for the exam, on the first page, I will give all of the common density functions of the distribution. So don't bother writing them down on your cheat sheet. Yeah. All right, so let's give it a try. I think it's a 2-page document. Oh, I think so. Let me see. Oh, maybe I need to do. Oh, yeah. Okay. Yeah. So let's do 1, 2, 3. At least, hopefully, as much as we can do today. And if we don't get to finish it next Wednesday, we're gonna finish the full conditional parameter, full conditional posterior distribution, so that we're able to make sure that we are on the same page, understanding Gibbs sampler. Okay. So give it a try. Step 1, 2, 3, as much as you can, and then in a few minutes, I will try to write out the beginning steps for them. All right, I think I was slowly building it up on the screen, but feel free to work at your own pace. And I will post the detailed solutions to this exercise on Moodle after class as well, so you can use that as a study material. But I would expect on Wednesday, we will talk about it a little bit more if we don't get to talk until the end of this material. Okay? So the likelihood, okay, so likelihood, as we know, is about both parameters, okay, and it should be the joint density. So I think it's always a good start to write it out slowly, okay, and each of them is IID Poisson, okay? So we can follow the Poisson density at the top, which, as we know, should be the product from 1 to m, and then we have lambda to the power of yi, exponent negative lambda divided by lambda I factorial. Okay, and as we know, we only really need to care about things about lambda and b And one thing you notice here, B doesn't really come into play. Okay, B is a next parameter that we use for lambda itself. So we only need to collect all of the terms about lambda, which we use this proportional sign of lambda to the power of sum of yi, and then in the exponent negative n times lambda. Okay, so this is actually exactly the same as what we did for the Gamma-Poisson derivation last week. Okay, even though we have this extra B parameter, but is a parameter for lambda itself. So B, we also call it hyperparameter, like what we talked about earlier. Okay. All right, the next step is write out the joint. Okay, this is the place that is different from what we did in class. In class for mu and phi, if you remember, we give independent priors for those. So the joint becomes the product of the two marginal. However, here, if you look at equation 4 and 5, what do we see over here? We see that we have a marginal prior for B, okay? And we actually have a conditional prior for lambda given B. So because of that, before you even think about both of them at gamma, let's try to write out mathematically what the joint prior distribution should be. So the joint of lambda and B, given the setup of 4 and 5, so this is part of the things that you need to read from the question itself, is we have a marginal of B, and then we multiply that by the conditional of lambda given B. So if I only look at this, I hope this makes sense to everybody, because the joint distribution, right, is the product of the marginal and the conditional. Okay? And this is also at the core of the Bayes rule that we used to do at the beginning. And once you get to this step, hopefully everything else is relatively straightforward, because, well, this is a gamma 1, 1, and this is a gamma 1b. So I just need to plug in the gamma densities that I have. So for simplicity, I'm just going to do the proportional one, because we only need to care everything about lambda and b. So, okay, maybe start with the proportional. Let me write it out as the first step. Okay, so we have the first one to be a gamma 1, 1. So what is that? We have 1 to the power of 1, okay, and then gamma 1, okay? And we're going to b to the power of 1 minus 1, and the exponent negative b. Okay, so this is the part about the first marginal prior of gamma. The second one is b to the power of 1, gamma 1 again, and then lambda to the power of b minus 1, oh sorry, 1 minus 1. 1 minus 1, okay? And then over there we have the exponent of negative b lambda. So if we drop the constants, keep everything about b and lambda, we can throw this way. I think this we can throw away, but there are other terms that we cannot. So in the end, I think we have b to the times exponent negative lambda b plus b. Okay, this is algebra, and of course you have plenty of time to do that after class. I just want to set this stage out. Okay, and then eventually, if I'm trying to write out the joint posterior distribution, okay, so I have this to be proportional to the prior, the joint prior, times the joint likelihood. So I just need to collect all of the terms, right? So for b, I also let's see, for lambda, I think I have lambda to the power of sum of yi, but I also have lambda, what do I have over here? Yeah, plus 1 minus 1, right? So plus 1 minus 1, let's keep it over there for now, okay? And then the other one in the exponent, I think we're gonna have n times lambda plus lambda b plus b. Okay? So this is collecting, combining the terms from step 1 and step 2. Make sense? Sense? Yeah, I mean, again, maybe not everybody have come to this stage yet, but the general step, make sure that we have the joint likelihood, we have the joint prior, and from there we can write out the joint posterior. This is exactly the same thing that we did for the Gibbs sample. Yes?
So for the high B,
yeah,
why do you still have B in the equation when it's gamma 1?
Oh yeah, so that B is coming from here. use different color.
Oh,
Yeah, it's coming from this part. You're right. So there's nothing of b because it's b to the power of 1 minus 1, which is 1, right? But that b is coming from actually the conditional prior.
and then what's in the exponent there?
Yeah, in the exponent here, this negative b times lambda.
On the other,
Yeah, the other exponent is just negative b. So that's why it is still here.
but shouldn't that be just be one?
You mean this one?
The one in the exponent. Yeah,
Why? Because it is still b, no?
but it's gamma 1 1, so it would be equal 1.
It's gamma 1 1, but it's okay. So I have to erase this in order to go up to the. But again, like I said, I'm gonna post the solution, so don't worry about it. But the particular question that Noah has is here. So gamma, that's the general gamma density, right? So if b follows a gamma, what do we have? Phi b is gonna be 1 to the power of 1, gamma 1, right? That's fine, right? That's the constant part. And then b to the power of 1 minus 1. And then in the exponent, we're gonna have negative b. So b is a parameter here. You cannot throw it away.
Okay.
B takes the place of 1.
Yeah, it is. Yeah, so that's the thing. So here I give 1 and 2 in the context of as much as I can. But of course, you need to pay attention to what is the random variable that you're working with. In this case, it's b. Then, well, this one goes away because it happens to go away. But you're still gonna have a term about b over here. Okay, so I'm gonna end here, but I will just say that there's a second page of this document. And that's the main part, okay, that you should try to find out the full conditional posterior distribution of 1 by 1. So that should be coming from the joint posterior. You take 1 as random, everything else is fixed, and try to recognize what the distribution is, okay? All right, let's end for today. And if anybody is having trouble or not having trouble running or installing round jacks, just let me know, because I'm not sure what the stage is. No matter what the outcome you have, just send me an email.
I figured it's the problem that I was on.
Oh, okay, all right. Let me stop here.
It was part of it.